We could not explain the silica repetition of 5. In the early 1900s, a Serbian scientist named Milankovic studied the Earth's position relative to other planets and came up with a theory of the ice ages that we now know is accurate. The gravitational pull of the sun and moon gently affect the Earth's motion and tilt towards the sun. During parts of this cycle, which can last tens of thousands of years, each of the Earth's hemispheres gets a little more or a little less solar radiation than they're used to, and that is where the fun begins. Milankovitch's theory initially assumed that a tilt of the Earth's hemisphere caused ravenous winter cold enough to turn the planets into ice. A Russian meteorologist named Vladimir Köppen dug deeply into Milankovitch's work and discovered a fascinating nuance. Moderately cool summers, not cold winters, were the icy culprit. It begins when a summer never gets warm enough to melt the previous winter's snow. The leftover ice base makes it easier for snow to accumulate the following winter, which increases the odds of snow sticking around in the following summer, which attracts even more accumulation the following winter. Perpetual snow reflects more of the sun rays, which exacerbates cooling, which brings more snowfall and on and on. Within a few hundred years, a seasonal snowpack grows into a continental ice sheet, and you're off to the races. The same thing happens in reverse. An orbital tilt, letting more sunlight in, melts more of the winter snowpack, which reflects less light the following years, which increases temperatures, which prevents more snow the next year, and so on. That's the cycle. Amazing thing here is how big something can grow from a relatively small change in conditions. You start with a thin layer of snow left over from a cool summer that no one would think anything of, and then, in geological blink of an eye, the entire Earth is covered in miles thick ice. As glaciologist Gwen Scholtz put it, it's not necessarily the amount of snow that causes ice sheets, but the fact that the snow, however little lasts. Big takeaway from ice ages is that you don't need tremendous force to create tremendous results. If something compounds, if a little growth serves as a fuel for